Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on 1-mark questions, important questions from optics for class 12. First of all, first question is, a diverging lens of focal length f is cut into two identical parts, each forming a plane concave lens. What is the focal length of each part? It will be twice the focal length of diverging lens. How? This is the lens, diverging lens, whose focal length is 1 by f equal to mu minus 1 into 1 by r1 minus 1 by r2. Because it is divided into two identical parts. It's possible only if radii of curvature are same. So r1 and r2 be taken to be r, but I have to choose the sign conventions for these. How can I choose? This is first surface having pole P1. First radius of curvature r1 is to the left of this pole, so it will be negative. So r1 will be minus r. And second pole is this P2, and radius of curvature r2 is to the right of this pole, which will be positive. So r2 will be plus r. After putting value, what I get? 1 by f equal to mu minus 1 minus 1 by r minus 1 by r. So it is minus 2 by r into mu minus 1. This is first equation. But if I divide this lens into two identical parts, what I get? I get two plano-concave lenses. But I consider one such lens first. So I have to find focal length of each part. So I will find focal length of one part. 1 by f dash equal to mu minus 1 into, now r1 is minus r, but r2 is plane surface. So radius of curvature for plane surface is infinity. So it will be minus 1 by r minus 1 by infinity. Anything divided by infinity will be 0. So it is minus 1 by r into mu minus 1. When I compare these two equations, what I get? 1 by f equal to 2 by f dash. So new focal length of one part will be twice the focal length already given to me. That is, the lens was having focal length f. So new focal length of one part will be twice this focal length f. A concave lens is placed in water. Will there be any change in focal length? Yes, it will increase, but nature of lens will not change. How it is? Because when I talk about air as medium, then this 1 by f1 is mu g by mu a minus 1 into 1 by r1 minus 1 by r2. Because here air is the medium, so mu a is 1 for air. So I can ignore this mu a in this equation. This is first part. Now, if I place this lens in water, then new focal length will be 1 by f2 equal to mu g by mu w. Now medium is water. So it will be mu g by mu w minus 1 into 1 by r1 minus 1 by r2. This term will remain same because I'm talking about same lens. One in air and second time in water. So when I divide this 1 by 2, what I get? f2 by f1 equal to mu g minus 1 upon mu g by mu w minus 1. ये जो रिफ्रैक्टिव इंडेक्स गिलास का है, ये वाटर से ज्यादा होता है. तो म्यू जी बाय म्यू डब्ल्यू ये रेशियो ग्रेटर देन 1 होगी. अगर ये रेशियो ग्रेटर देन 1 है तो कैलकुलेशन से ये क्लियर हो जाता है कि f2 इज ग्रेटर देन f1. f2 क्या लिया हुआ है? फोकल लेंथ ऑफ लेंस इन वाटर. एंड f1 क्या लिया हुआ है? फोकल लेंथ ऑफ लेंस इन एयर. तो वाटर में फोकल लेंथ इंक्रीज हो जाएगी. सो यस, देयर विल बी इंक्रीज इन फोकल लेंथ व्हेन लेंस इज प्लेस्ड इन वाटर, but nature of lens will be same. अगर पूछे ना nature of lens क्या होगी, तो it will remain same. So this was the second answer. Now for third, draw the diagram to show the behavior of plane wavefronts as they pass through a thin prism. So I draw the prism. Two rays I am taking to be incident on this prism, P ray and Q ray. Now what I do? I take segment equal to QR on PS. Mark the point here. I will join this R with P. This will be the plane wavefront incident on prism. So there will be dispersion. This will be the path of the ray. Rays coming out from the prism. After undergoing reflection at these two ends, This UV is the emergent ray. Similarly, WX is also emergent ray. What I do? I take segment equal to UV on WX and mark the point here. Join this U with this point, that it is Z. So this UZ is again a wavefront which is planar. That means emergent wavefront will also be plane in nature. This is the diagram to show the plane wavefronts passing through the thin prism. When they pass through thin convex lens, that means plane wavefront means rays are coming from infinity. So this is the plane wavefront incident on this convex lens. Now what happens if we know that rays are coming from infinity? They meet at single point known as focus after reflection to convex lens. So when I draw the wavefront, it will be spherical. That means refracted wavefront is spherical. When this plane wavefront is incident on thin convex lens, we get refracted wavefront as spherical in shape. Draw a plot showing the variation of power of lens with the wavefront of the incident light. We know that refractive index by Cauchy relation is given by A plus B by lambda square plus C by lambda 4 and so on. I can neglect higher terms. So what I find that N is inversely proportional to square of the wavelength. Now, this power of lens is N minus 1 into 1 by R1 minus 1 by R2. N is the refractive index. So what I find that refractive index decreases with increase in wavelength. More the wavelength, lesser is the refractive index. And if this refractive index is less, this term is less from which minus 1 is being done, then this power will also decrease. So power is also related to wavelength because N is proportional to 1 by lambda square and power is directly proportional to N minus 1. So P will also be nearly proportional to lambda square. So what will be the shape? The shape of graph between P versus lambda will be exponent. P versus lambda, this will be the shape of graph. So in exam, what you have to write? First, write reason P is inversely proportional to lambda square and then draw this graph. This all explanation I gave you to understand dependence of power of lens with wavelength. Thanks for watching this video. Like, share, subscribe my channel.